Hello, boys and girls. You're about to watch a lesson on combining like terms. So we start off with this opening exercise about pineapples and apples. So I'll read it out for you. Below are groups of pineapples and apples. Represent each pineapple with a P and each apple with an A. Write two different expressions that we could use to determine the total number of pineapples and the total number of apples. So what I would do is I'm just going to represent A for apples. So you can see that I could represent these with variable. And then for pineapples, they want us to use the variable P. So you can see how many apples there are and how many pineapples. So if I ask you how many apples are there, many of you would say 6 apples. So couldn't I just represent that with 6A, which is the number of apples? And I want to have how many pineapples? 3 pineapples. What would I do to the pineapples and apples to figure out the total number of both? You would add them. Another expression would be the really long one, is we could take the apple plus another apple plus another one. You would end up adding repeatedly 6 times to show the 6 apples, and you could do the same thing for pineapples. Now I'd be curious if anybody would remember how to use distributive property for this. Can anyone think of the greatest common factor? We could factor out 3. And then 3 times what is 6A? So we can have 3 times 2 apples. Plus 3 times what would give you 3P? 1P. So both of these would work. So the idea is for you to see that we can't mush these together. One common thing students make is they want to say 6A plus 3P is 9AP. That is a big fat no. Okay? We cannot combine them. The apples and pineapples are not the same fruit. Okay, so that's the whole objective of that. The next piece goes over vocabulary. And this is a nice little sentence frame activity where you're forced to use the math term. So a term, see if you guys remember that. A term is part of an expression. So an example of a term would be something like this. If I had pineapples and apples example, 6A plus 3P. This is a term. This is a term. So how many terms do you see in these two? 2. Okay. Like terms are terms that have the same variable raised to the same power. What does that mean? So let's say I had x squared plus 3x squared. These are considered like terms because they have the same variable, they both have an x, but both variables are also raised to the second power. So an example of unlike terms would be something like this, x squared plus x. These are not like terms because they're not both raised to the second power, okay? Expression can be simplified by combining them. So I could take this and make a one term by combining them. So these are called like terms. Okay. Both the original expression and the simplified expression would be considered simplified, equivalent. So for example, x squared plus 3x squared, I could combine these because we have like term, same variable raised to the same power, by adding 1x squared to 3x squared to get 4x squared. These are both equivalent expressions. So down here I left you some steps on when you're simplifying expression. The first thing I would do is I would look through all the terms. If any terms have no coefficient, if you don't remember what coefficient means, for example, see this variable? I don't see a coefficient. Coefficient what you're multiplying your variable by. Add a 1 there just so you know that that means 1. If the variable has no exponent, write 1x the exponent. You don't really need to do that part. But what they're saying is understand that this is raised to the first power. We just wouldn't normally see that. Box the first term in the expression. So that's what I did here. Box the first term. And the sign. Box all other terms to the right that are like the term. So do you see any other that have the same variable raised to the same power? Over here. And you want to box in that subtraction symbol so that you know you're doing 4x minus 2x to get 2x. Okay? Circle the next term, so the next term in the expression including the sign. So here I see 12 minus 4, those are like terms. They're both called constant, where you don't have a variable. So I would do 12 minus 4, and I would actually get 8. Finish identifying like term. So when I look in here, I don't see a like term for 1x squared, so I leave that as is. So my expression would be x squared, that's here, plus 2x, which I got from here, plus 8. So these expressions are both equivalent. This is the simplified version. Example 2 is just more practice on that. I started it for you. First, circle the first term. Do you see any like terms? Same variable raised to the same power? You do right here. 8k squared plus k squared. Remember, that means you have a 1 in front. So you're doing 8 plus 1. Get 9k squared. Square the next term. I see another k over here, but it's a subtraction. So we're going to do 4k minus k to get 3k. I don't see any like terms for 3k to the third, so that stays, and I don't see any other constant. So I'm looking for 3k to the third, which I got from here, plus 9k squared, which I got from here, plus 3k, which is from here, and then don't forget about that constant. And there we are right here. One way to remember is when you do the order, I always put the variable raised to the larger power in the front, and then I just put it in order. The next one is applying it to perimeter. You have to write an expression that is equivalent to the perimeter of the triangle below. So if I look, how would you find the perimeter? The perimeter is when you take the length and you add it to all the other length. Like if I were to have a fence in yard for a dog, I need to add up the total length. So I don't know what the length is, but I have an expression. So I would take whatever this length is, 2x plus 4. I would add it to whatever this length is, which is 4 times x, plus whatever this length is. We can simplify this. So this is one expression that I could use, but let's simplify that by combining like terms. So circle the first term. Do you see any other like term? X, I do, plus 4x plus 5x. 2x plus 4x is 6x, plus 5x is 11x. And then I have box plus 4. Do you see any other constant? Minus 1. 4 minus 1 equals 3. So I'm left with 11x plus 3. Tomorrow we're going to do more practice with this, but I wanted you to have some notes completed for tomorrow's activity. Hope you understood it.